The problem that we are going to look into today is Amazon Alexa review. This is a sentiment analysis. So this is a text mining work. And here we are going to build classification model to check if the sentiment of a particular sentence is positive or negative. So here initially we import the required libraries. So these are the various libraries which we are going to need. And we are also going to need word cloud. So just to understand what are the commonly spoken words or commonly discussed words in these sentiments. So this particular Amazon Alexa reviews, this is a TSV. TSV is a tab separated file. And here we have the data set which has 5 columns and 3150 records. The columns are the rating, the date on which the rating is given, the variation, that is Alexa is there in various variations, like there is echo dot, so the variation, what is the review and what is the feedback, whether it is positive or negative. So these are the various columns. Checking for the null value, only in the reviews that there is a null value. Only there is one record with no reviews. So here alone there is one record only, and so that record alone can be dropped. So after dropping the null values, we have 3149 records. And then here we want to capture, now we are going to perform analysis on these verified reviews mostly, because our topic is sentiment analysis. And so now we are going to capture what is the length of these reviews. We want to understand how does the length of the review affect the sentiment, like are the people giving longer reviews when it is a negative sentiment. So we apply the length function and store it in a column which is length. So we randomly check for some 10th record, and so this is the verified reviews. This is the reviews. I sent it to my 85-year-old dad and he talks to it constantly. And the length of the review is 65. So the length of the review is the same as what we have stored in our data set, indicating what we have stored is correct. So this is the length, number of characters that are there. Now all these columns are of various data types, like rating is integer, date is an object, variation is an object, verified reviews is an object. Rating, feedback and length are integer values, whereas date, variation and verified reviews are string values. So if now we are going to analyze the rating column. Now the rating column has 5, 4, 3, 2, 1 and there are 5, 2, 2, 8, 6, 4, 4, 5, 5, 3 rating 152, 2 rating 95 and 1 rating is given by 161 people. So now to check the bar graph, this is the bar graph that we get, where mostly we see that it is a 5, but one is almost equal to 3, indicating that there are people who have not liked the product at all. So this is the percentage out of 100, and if we have to plot this in a pie, so this is 5, this is 2, 3, 1 and 4. Checking on the feedback column. So now the feedback is 0 or a 1, indicating if it is a positive or a negative sentiment. So 0, that is there are 256 reviews that are negative and 2893 reviews that are positive. So now we are just checking on the first review that has the negative feedback. Sound is terrible, if you want good music to get a Bose. get a Bose speaker. So now this is the review. This is the review of the first negative feedback. Similarly, for the initial, for the good feedback, it is loved it. From the two example, we can see that the feedback 0 is negative review and 1 is positive review. Now, if we have to plot the reviews 1 and 0, this is 1 and mostly it is 0. Mostly it is 1 and the rest are 0. And this is the percentage distribution. Similarly, the figure for this. Now let us check for 0, what is the rating that is given. If it is a negative feedback, what is the rating? So if it is a negative feedback, it is 161 and 95. Rating is 1 and 2. If it is 1 feedback, it is 3, 4 and 5 review. If rating is 1 or 2, then the feedback is 0. Otherwise, if the rating is 3, 4 or 5, then the feedback is 1. Checking on the variation column, we have various products that are there, like black dot, black plus, black show. Then there is oak finish, walnut finish, and so on. And this shows the count for each of these and the percentage count of all of these. Now, checking on the variation and the rating, the mean for those ratings. So almost all have similar distributions, 4 point something, indicating that there is not one particular product which has gone down. Rather, the review is mixed for each of the variation. Like, let's say if one would have been very less, indicating white spot has always got bad reviews, has always got a bad rating. But that's not the case, indicating that the rating is uniform across all kinds of variations of the product. So this is the mean rating. But for white, we see that for white it is slightly lesser when compared to, let's say, the last one, which has almost the walnut finish, which has almost the higher rating. So on this basis, we can decide what are the products which are being received well. Checking on the length column, minimum is 1, maximum is 2853. Somebody has given a very long review. 75% has 166 and 54% has 74 as the data. So this is the distribution of the length of the review, where only one, there is one review with 2300 or something, one with 2800, and there are 500 and plus reviews with length 1 or maybe 1 to 10 or something, 1 to 20 or so. Distribution of length of review if the feedback is 0. If the feedback is 0, we can see it's a smaller feedback. See, this is the count. See, the longer feedback has been given when the feedback was good. So 2600, 2800 are given when the feedback was good. The next is lengthwise mean rating. So here we are checking on the length and what is the effect of this length on the rating. So this is the rating that we have and this is the length. So here we check what is the effect of ratings on length. So see, longer the review, higher the rating. For 1 and 2 we can see it's like mostly shorter reviews. Now applying count vectorizer on the verified reviews, and then we combine all the reviews and try to generate the word cloud for all the reviews. So mostly it is love, Alexa, great, easy, far, better. These are the mostly used words. Now we will try to check on the unique words in each feedback category. So we have negative reviews and then we have positive reviews. Generating the word cloud for this is the word cloud for the negative reviews. So there is back, repair, garbage, horrible, Alexa, cycle, working, Bluetooth. So now from this I get to know what are the areas which need improvement, and this is the word cloud for positive reviews. Room, learning, bedroom, love, Alexa, camera, sound, expected, learn, option. So this shows me what is being liked by people. Coming to the pre-processing and modeling, here we perform Porter stemmer, convert all the reviews to lowercase, remove the stop words, and also join the reviews back into the sentence form, and use count vectorizer to create bag of words model. So that becomes the X data set, and then we have the Y data set. If we want, we can save this file, that is the count vectorizer object. So I will get 3149, 2500 features is what I've captured here in the bag of words model, and that is my X, and the Y is 3149, zeros or ones. So splitting the data set into 70-30 ratio. Now we scale the values using the min-max scaler. Again, this scalar object can be saved using pickle.dump method. Applying the random forest on these, we get a good accuracy of 99% and a text accuracy of 94%. And then predicting it on the test set, creating the confusion matrix shows that this is a good accuracy, that is 32 and 860 are correctly judged, whereas 46 and 7 are in the wrong category. Now there is k-fold cross validation. After applying k-fold cross validation, the accuracy came to 93. We also apply grid search on the model to get the best set of parameters, and so the cross validation mean accuracy on the test set is 96.8, and the cross validation mean accuracy on the test set is 92. And here accuracy score for the test set is 94. Now we apply the XGBoost model, and XGBoost model has also given us 0.97 as the accuracy and 0.94 as the testing accuracy, which is again a good accuracy that is there. Applying the decision tree has again given 0.99 and 0.92. Now in such kind of cases we can just check like what is important, like is it the precision, is it the recall, or a combination of both can be seen using F1 score. I will give a link to this particular notebook.